I don't know when it's due. All right. No, you got 24 hours to take it. And after 24 hours, you can add 5 minutes if you need it.
You've got 90 minutes.
You get 5 tries by us and you do it once while you look it up and then you come back.
Okay, well, that ain't how it works.
All right, this question, I just wanted to make sure I went over blinded because I didn't know this question was on here. It says, how can making an experiment single blind or double blind help? If you're going to do it to one group, you do it to what? Both groups. That's what double blinded means. If I'm going to give you a red pill and say it's fake, then I'm going to give you a blue pill and say it's fake. I'm going to do it with both sides. That's what it says. If an experiment is blinded, then the effect arising from the physical should affect all groups equally. Okay, so that's what blinded means. I'm not going to worry too much about that one because it's only part that you can, especially if you take the test one time, you can look at it and say, okay, there's the answer, and then when it comes up again, hit the answer.
But you might not get it the second time.
Well, then you just jump up and down and be happy. All right. This problem.
Oh, okay, just go on.
No, I want to go over it. First of all, when you look at this problem, the first thing you're going to see is, okay, there's a normal distribution. Well, it's not. And I'm going to take my handy-dandy whiteboard. What?
No, I mean, okay, I have trouble with those peaks. Okay, obviously, I say there's 2 peaks in that, but I think I remember maybe you saying that you can't.
Oh, don't blame it on me.
No, listen, you don't have a curve that does all this, okay? It can't.
Okay, first of all, you're looking for tendencies. The normal distribution curve has a middle, and then the hump is in the middle, and it's symmetrical on both sides, okay? In other words, this side looks like this side, all right? Other than that, you have skewed right or skewed left, which all your data is on the right side, and you have skewed right, which all your data is on the left side, all right? Now, tendencies, you're looking for tendencies and you're looking for peaks. That's what you're looking for. Because this is a peak, this is a peak, and this is a peak. You got 2 peaks. You got one little peak right here, and you got another big peak right here. So what I tell students to do is draw a line. And somewhere around center is right about here. Okay? Because 50, this is 40, 40 to 100 is 60, half of 60 is 30, so 40 plus 30 is 70, 75 is somewhere around here is center. So what is this one? Well, you got 2 peaks, a small peak and a large peak, and it looks a little bit skewed what? Left, because your data is a little bit to the right. The only normal you're going to see is when you got this. I'll show you. Here's what normal will look like. Take my handy dandy white. That's what a normal will look like. It'll look something like that. In other words, if you see 2 peaks, it's not normal. If there's a bunch of variation, it's not normal. The only time you're going to see normal is when you take your pencil and you draw on the, not on the screen, please don't draw on the screen, but you see that hump and the middle is right here in the middle, then yes, this is going to be, it's either going to be a normal distribution or it's going to be skewed left, skewed right, something like that. Or it's going to be all over the place, and I don't know if they got one there. Yeah, wide variation, that's all over the place. Huh? Wide variation means all over the place. Low variation means what? Tighter. 1 peak, symmetric is that. 3-piece, this is all over the place. 1 peak, right, skewed, is that one. 2 peaks, left skewed, that one right there, but this one has 2 peaks, so it's got one right about there too. Okay? So that's kind of just interpretation. That's again why I'm giving you extra problems, so extra attempts. They don't want y'all mad at me. Okay, get rid of that, get rid of that. Next one. And this is the one I need to go over with you, and we'll do a couple of these. Yeah. Okay. Okay, let me
I'm the only person that's taking the test.
probably.
I haven't had to do it.
Okay, write this question down. Now there's 3 or 4 different ways to do this problem. 2 that will give you the answer and 1 that won't, but it'll give you a common sense answer. Or you can just work with it. Now, there's one little part at the end that we didn't cover. They're not asking you for the z-score, they're asking you for the x. And I forgot to show you the formula for x. It says the score for a certain test, intelligence test, or whatever it says, are normally distributed with a mean of 75 and a standard deviation of whatever it comes out to be. I'm not looking at it right now. $17. So somebody tell me what 75 plus 17 is. 92? Huh? And then 92 plus 17 is 109. And 128. 126. And then 75 minus 17. And minus 17. And minus 17. Okay. So, and they say, we've done all this, find the 80th percentile. Well, by the empirical rule, we know that this right here is 50%, right? Because this is 34, this is 13.5, and this is 2.5, so that's equal to 50. So at the mean, that's 50. So 34 is right here by the empirical rule. So 50 plus 34 is what? So at this point, that's 84%. So common sense wise means that my answer is probably going to fall between 0.5 and 1 as far as the z-score, right? So that's just common sense. The empirical rule will only tell you where you're going to fall. It's not going to tell you exactly, okay, unless it falls on one of these numbers like -3, -2, -1, 0, 1, 2, 3. So this one's not going to fall on that because we just saw that that's 84%. We want 80%. So the area under the curve that they're looking for, I'm going to put it in red, not because I just want you to see it. This area is 0.8000, or in the dumb stupid book, 80.00. Okay. So in 90% of your probability books, it's 0.8000. In this book, it's 80.000. So there's 2 ways to find this. You got to find this z-score right here. That gives you a 0.8. So you either got to look in the table at 80% or you use your calculator. The calculator is a little bit more accurate, so I'm going to tell you to use it. If you don't have a calculator, then you use the table. I'll tell you how to do that. So second, bars, and then inverse norm and then type in 0.8000 and enter. And what does that give us? 841.
6, 2, 1, 2, 3, 3, 5.
All right, these scores are only to the second.
Is that right?
Yes. Half of it just disappeared. 0.84. So I'm going to say equals 0.84. That's my z-score. So at this point right here is 0.84. Now, is that what we said as far as common sense? Yes, we said it was between 0.5 and what? 1. Everybody with me? Now, that's not what they want though. They say find the 80th percentile of these scores. Now, I don't agree with the question. I would rather they say find what score represents the 80th percentile. So I don't agree with this. I think it's a poorly written question. But they're asking for the score, not the z-score. So they're asking, what do I need to make on the test to be above the 80th percentile? That's what they're asking. Right now, the scores are between 75 and 92. 92, if you made a 98, would you be above the 84th percentile or below the 84th percentile? Above it. 98 would be right in here. They're wanting to know the score that represents the 80th percentile. Right now, we got a z-score. So you got to use the formula that you don't know because I had shown it to you, or solve this formula. C is equal to x minus x bar over standard deviation. Or solve this for x. So I'm not going to ask you to solve for it because I'm just telling you that x is equal to odds plus mu. Now I write it like that because if I wrote it the other way, it would be x is equal to sz plus x bar, and you wouldn't remember. So I put it in the population and say odds plus mu, because you can remember odds plus mu. Odds like Dr. Oz, like the Wizard of Oz, plus mu. Now what is mu? Average, mean, x bar. Okay? What is the O? That's standard deviation. That's your population parameters for mean and standard deviation. Now what do you think Z is? Z-score. So now I'm going to take x, I'm going to find x is equal to 17 times my z-score is 0.84 and add 75. Now let me ask y'all a question. What do you think the score is going to be? I say it's going to be around 87, 88. I'm just guessing. Why? Because you know that this is 0.84, and 0.84 is 75 to 92. You could say around 90. But just guessing using for the empirical rule, I would say 87 to 90, somewhere in there. I may be totally wrong. But when you add these numbers up and you multiply these two numbers and add this number, what do you get? 89 point what?
28.
Now the directions say round to the nearest whole number, so that would be 89. No, that's the answer.
I'm about to say
Yeah, I already looked at what she put. It says this person does not know what she's doing. That's what it said.
I put 100. Gives you the right answer after you give you the answer.
No, it only gives you the right answer.
That's
It's the bid that
Yeah, that's
says.
the same right there. It gives you the right answer.
Okay, so what we're going to do is I want you to write down 6C41. Write that down. And I'm going to go and pull this up, and we're going to do a couple of them. So that way everybody will have them.
It's pretty easy.
6C41. Yeah, after the teacher shows you how to do it. Kind of helps for the teacher to show you these things.
Thank you.
You're welcome. What?
They're thanking me for
Yeah, for doing my job.
For being
Yeah.
a weirdo.
Yep. All right. Main.
Just like.
No, I suck. I suck because I didn't show y'all how to do that. I didn't see any problems that we went over that had that in there.
But listen, in my homework, I didn't, because I went back to my homework,
Uh-huh.
and there are no problems like that in my homework.
Okay, then that means they didn't put it in there, whoever's in charge of this class. So I gotta go to chapter contents, and I'm gonna go to
I
chapter
think mine went to
6.
like section C31.
C. And now you'll see 41. That's why I do problems out of the study plan, because some of these teachers don't put enough problems in there. There we go. All right, do this one. First thing I want you to do is draw a normal curve, do the empirical rule, and get an idea of where the answer is. It says, the scores for a certain test of intelligence are normally distributed with a mean of 95 and a standard deviation of 12. Find the 80th percentile of these scores. Then rewrite that. Find the score that represents the 80th percentile. Find the test score that represents the 80th percentile. Because the way they write it is not correct. Not correct. Lead. Oh no, I suck. They called him after a shootout. Well, if they were smart, that's what I'd do. That's why I couldn't be a policeman. If you just blew up somebody, or blew up a, don't even ask me where I'm aiming. Because I don't want to have to put up with your butt down at Gitmo or whatever. I have no idea. Heck, no, man. I ain't even done the problem. I'm waiting on y'all. Please. Making noise. Just type in word. All right, here we go. $95, $105, $107, $105, $215,
$119,
$131.
and $131.
And what's this side?
83, 71, 59.
So 50% is right here. So 84% would be right here. So again, we're going to fall right in here at 80%. And that means that your area under the curve is 0.8000 or 80%. So we need to find that z-score right here. So what we need to do is put up inverse norm of 0.8. What do you get? Inverse norm of 0.8000. 0.84. And then x is equal to Oz plus mu. So that's going to be 12 times 0.84 plus 95, and that's equal to what? 105.08, and that's 105. And now let's look at our, does that make sense? Because the next number is 107. Yeah, if you want to pull up the table, you pull up and look up 80%. Now there's a little bit of interpolation here, or a little bit of interpolation also. 80% falls where? Well, I'm looking.
You got to scroll down.
Right here. Now, what's closer? 81 cents to a dollar or 23 cents over a dollar? Well, 81 cents is 19 cents closer to the dollar. So the z-score is 0.8. Now, where they're getting, I don't know how you get 0.84 here, but I'm going to do something and check. They're going to have to give you a tolerance here. And let me show you what I'm talking about. If I was to give you here's 80. 80 is going to be pretty much in the middle, right? So I'd say it's probably 0.825 is what I would say. That's what I would say, or 0.83, because it says round to the nearest whole or whatever. So I'm going to say 0.83. Somebody type in 0.83 times, times 12 plus 95. What do you get? And what does the direction say? Round to the nearest what? That's why they're rounding it to the nearest whole, because they know that the table is different from the calculator. Now, also, look here. Well, that's why if I typed in the wrong answer, let's say 3 and 3 and 3. Yeah, they're not going to, usually they give you if there's a rounding problem, like if you get something to the 10,000th and the graph, the table is different from the calculator, they'll give you like to the 10,000th of a tolerance. Like they'll give you 0.0002 plus or minus. So your answer could be above or below the middle. So usually they do that. But in this case, they didn't do that. They just said round to the nearest whole, and that takes in all the difference between the table and the calculator.
Just clarification. So if we use the calculator and we use that formula, we don't have to use the table.
Yeah, table's only for not calculator, yes. Okay?
Can we do one more?
Yep. I would like to do one with different numbers. Let me see if the next one is.
You got the 0.8 from the 80%.
0.8 from the inverse norm. The calculator. Yeah, this is different numbers. Yeah, I'd quit. Can't do those big numbers. Gotta quit. That's like having 6 in on the cash register.
Okay, now this one's different because we're going to be subtracting the environment. So we can talk
Scores on the quantitative portion of the examination. Student scores normally distributed. What percentage of students are taking the quantitative exam? They're asking for the area. It's the same, pretty much the same type question. You're just not going to use Oz plus mu. but you can tell from the empirical, draw a picture, and you have to draw a picture on these things. The reason you have to draw a picture is to make sure you know what you're doing. So I'm going to go ahead and draw a picture. So we got a normal distribution. $576 is in the middle. You don't have to add them for me and subtract them for me. So 576 is right here. Add them for me. 716. 850 what? And the left?
436. 296.
That's good. And they're wanting to know what percentage of students are at 604. So take 576 plus 716 and divide it by 2. What do you get?
646.
So 646 is right here. They want to know 604. 576 to 646 is what? 70, half of 70 is 35. 30 plus this is 606. So 606 is right in here. So somebody tell me what z-score you think is going to fall around. Okay, I got 0.55, okay. And you also see that, you're talking about how many, this is 50%. What is this? Well, I don't know, 51%? I don't know. But it's over 50 what? Percent. So you know from common sense that your answer, I can't spell, is going to be between what? It's going to be between 50 and 55%. I don't know. 34, half of 34 is 17, right? 67%. You know it's going to be between 50 and 67%. You also going to know it's going to be between what z-scores? It's going to be between 0 and what? 0.5 on the z-scores. You also know it's going to be between 576 and what? 606. That's why the picture is important. Remember, just doing the math is good, but knowing what you're doing is even better. So that's why you draw a picture. And so we got that number. So we're going to need a z-score, or let's see, it says at 604. So 604 minus 576 divided by 1 what? 140. And that's equal to what?
I got 0.214.
0.214 or 0.21. Now take your handy dandy calculator out and do normal CDF and go from negative infinity to 0.21. And somebody tell me what you get. Second bar is normal CDF, and then type in negative 99999, comma, 0.21.
Alright, I got that different. And what's the upper?
The upper is 0.21. The lower is negative 0.9999. And use the negative down at the bottom.
And then you need to make sure you put that on the demonstration. Did you start with
I thought I did that.
talking about how to use it? Oh, I hadn't watched it.
I did. It's on there.
I didn't know that when I first started.
It's on there. Especially with graphing. I say it with graphing. On the graphing section of how to use your calculator.
Did you start the recording?
Yeah, I did. Okay. So what'd you get? I'm sorry, what? 70, that's right on the, not common sense. So you've done something wrong.
Okay, well, my calculator asks for more stuff. It reads the mean and the standard deviation.
Go ahead and type it in.
Oh, yeah, I didn't do that.
All right, does that make sense? Well, mine's a little bit off. I said between 0 and 0.5, so I'm a little bit off. So what'd you get? 583 or 58. Since we're looking for a z-score, what did it say? What percentage? Oh, 58%. Oh, okay. So my percent is right. I'm between 50 and what? 67%. I'm at 58. What does it say? Round to the nearest what? So your answer is 58%. Now look at your table. Pull up your handy dandy table, and you're looking for point. Where's my z-score? Oh, 0.21. So pull up your handy dandy table and look for a z-score of 0.21. Okay, I can't move it. You won't move. Okay. 0.21. There it is. 0.21 gives us what? 57.93, which is 58. So that's why they're telling you to raise to the nearest whole number to bypass any rounding issues.
Yeah, I didn't get the same thing. I got 1.95.
All right, so here we go. Second bars, normal CDF, negative 99999, comma, 0.21, close parentheses, enter.
How do you do the comment?
It's right there above the 7. I think y'all need to take my how to use a calculator class. It's free.
No, actually, mine is worn off, so I didn't have it.
Okay, let's think off fingernail polish. What do y'all need?
0.58.
Oh, y'all need help.
Yeah.
Perfect.
Well, okay, I put
I put it in parentheses and I'm still not doing it right. Look at her.
I got it right.
Base.
That's
Mm-hmm. I don't know what that is.
Yeah.
No, it's doing something wrong. Hold on.
Okay, wait.
I took it. I just
How
put
can
it in
two
parentheses.
calculators do the same
Second.
thing?
Bars. They both got screwed up operators.
Thank you.
7.5.
They both have hot operators.
Negative. I didn't say 0.99999.
I didn't put 0.99999.
9999.
See, and it sounds like hers did.
Okay, see, look,
That's
I've got
what-
the
that's
lower is
hers.
negative 99999, upper is 0.21, the mean is 576,
I
and the
have no
standard deviation
idea.
is 140.
And hers says the same thing because she got 1 point. Yeah. Hers is the same.
Let me try something else.
Okay, but now it is to the negative, so see, are we supposed
Still,
to
that's
move
not
the,
right. This should be
For those of you calculators.
negative. Still has different answers every time.
Yeah, hers is the same way.
It's those new calculators.
well, I will tell you, the older one, I took the top of stats class and I did like it.
Yeah.
Yeah, because it's,
We gotta figure this out, because I don't
What if you,
understand.
okay, do it without entering the mean and the standard deviation, see what it does.
Second bars, another CBF. Why is it asking? It's asking me for the other one. Why is it doing that? Second.
Okay, look, if you don't put in the mean and standard deviation, it comes up with the wrong answer.
Well, why does it ask for it?
I don't know, but see, I did it that way, I didn't put those other, that other information in the right.
Lower is point. Oh, I know why. It's asking, okay, when you put that mean and standard deviation in there, it's changing the fact that you're dealing with a z-score. You're dealing with z-scores. That's why you need to leave it at 0 and 1. It's changing the problem altogether when you put the standard deviation in there. You leave it 0 and 1 because you're dealing with z-scores. That's why. All right, so lower is negative 999.21. And you paste. There. You're right. That's why.
Same thing is, is you use the calculator, you never know the answer.
No, you just don't. No, you don't. On this, you're dealing with z-scores, so you leave it at 0 and
But
1.
listen, here's the thing, once you do it on your calculator, you can always go take that table and check your work.
Yeah.
But they don't match, then you're wrong.
Yeah, but that would take extra what?
Work.
Work. And some of our students, that, you know, some of our students in my other 4 classes, they want a trophy for what? Participating. Okay, they don't want to work and excel. They just want to, you know, get a degree. If they get a degree, then they get a job, and if they get a job, they get a paycheck. Nobody said anything about work. What? I didn't hear what he said.
He says, can you not just print off a degree?
Yeah, you can fill it out and use that. Yep. George Clooney did it in No Brother Where Art Thou. All right, let's get back to where we were now that I'm totally okay. So did we look it up on here? Did it come out to be right?
Yes.
Okay, good. And okay, let me go back and
Too
do
many
one.
numbers in that one.
Yeah, too many. Yeah, don't want to do that. Suppose you read that the average height of a class of 38 eighth graders is 62 inches with a mean, with a standard deviation of 38, average and a mean of 38. Is this likely? Explain. Why do they ask likely? Why don't they say, is this normal? This book is so bass backwards. I'm sorry, but y'all not getting the money's worth out of this book. All right, do this one. Suppose that you read that the mean is 38 and the average height is 38 eighth graders. The mean is 62 and the standard deviation is 38. Draw a picture. I don't even know what it's asking, but the first thing I do when I do these is I draw
Because
a
that
picture.
38 eighth graders, you don't need that number.
It's a red herring. At least I think it is. 62. And what's 62 plus 38? 90, 100? And 138. And what's 62 minus 30? Thank you. And 24 minus 38. And they're asking you, suppose you read that the average height for the class of 38 eighth graders is 62 inches with a standard deviation of 38 inches. The only reason I say it's not likely is because what? Negative. But I don't know. Let's see what the options say. This is not likely because the mean is 62 and standard deviation will imply that about 5% of the heights differ. I would agree with that. Somebody take 100 divided by 60 to see. New minus old over old. Take 100 minus 62 and divide it by 62. What do you get? So that's 61% difference. So that's a possibility. This is likely because a mean of 62 inches is a very plausible height for an 8th grader, according to who? This is likely because the heights are often accurately approximated by the normal distribution. This is not likely because the heights are usually not approximated by the normal distribution. I would say it's A, because that's an awfully large spread. Huh? And what does it also give us? So if you're going to be unusual in this group, you got to be non-existent. Because once you get down to 0 height, you disappear. Yeah, dang old black hole, dang old matter, dang old implosion on itself. So I'm going to say A. I feel good about myself. So I don't need smokestacks on my truck. All right, so that's that. So let's go back to the test. Wherever it went, I bet it went away. Did it go away? I doubt it. So we're going to go back to the grade book. I love that song. Me and my daughter used to sing that song all the time. That was the only song on that whole show I liked. All right. Okay, be quiet.
Hey.
All right. What is this thing doing? Well, the first thing you do is take your handy dandy straight line maker or your ruler. And what kind of correlation is that? It's negative. And there's a strong negative correlation. And let's see what else it says.
Okay, well, it should be common sense that heavier cars get higher gas mileage. It should be A.
No, heavier cars get lower. The heavier the car, the more it has to pull.
Oh, well, that's why I got it
You
wrong.
just got confused. You got confused. You didn't take your medication, you know, that's all. Drink
No, I'm thinking, okay,
Merlot or
I'm thinking
Cabernet Sauvignon
heavier
goes good with
cars,
this.
You spend more money on gas, is what I'm thinking. Okay,
The heavier the car.
you spend more on gas.
Yeah. Because the
But that's not
mileage
the way it's
sucks.
worded. Okay.
Yeah, you just have to think about it.
Now, right here, this one. I knew the answer had to equal 100%, but you had to round all that stuff up. Like, go look and see what it actually looks like. Go click on it.
Let me read the question
Okay.
first. Use 4-point bins. That means classes. Never heard it called bins. In all my, never seen it called bins. To make a frequency table, okay, I'm going to take my handy dandy Excel spreadsheet. 96 to 99 is our first one, right? 96 to 99. And I'm just going to put over here 96 to 99. Well, it's not nothing because it's stupid button. I hate that button. 96 to 99. So what's the next one? 100 to what? Well, the class width is 96, 97, 98, 99, 4, right? Is it 4? Yep. 100 to what? Well, what's 99 minus 4? I mean, nothing. 100 minus 96 is 4. So what's this one? 99 would be 103. You have to do it like that when you're making up. I can't. 103. There we go. And then the next one is 104.
You're going down in numbers.
Yeah. Does it not want us to do that?
But it's supposed to be like lower numbers.
We didn't put them in order, that's for sure. Okay. Why'd they start it?
Maybe that's already the high number.
I told y'all I hated this book. Okay.
I'm doing things I hate too.
Yeah, every problem in the probability class, we start at the top and go down. 76 to 79, sorry, I'm being sarcastic. 76, that's why it's so hard to do it the other way. 79, and then what? 80 to what? 80 to plus 4 is 83, and then 84 plus 3 is 87, and then what? No, that's not.
Thank God I didn't have to fix my own classes.
79, 4, and 4 is 87, and then 88, thank you, 91, and then what? 92 to 95. How far we got to go? Okay, then 96 to what? 99. And how many? Well, 76 to 79, right there. So we'll color those that color. So there's 4. 80 to 83 is 4. Oops. No. I'm sorry, hold on. What? 84 to 87 is 4. 88 to 95 is 3. 96 to 95, wait a minute. 92.
Right.
What?
It's supposed to be 88 to 95. That 91.
No,
No,
go back to the real thing.
Yeah, you got the next thing down at 96, and 96, 98.
76 to 79, what do I got? Y'all check me.
That's right.
Yeah, I'm wrong.
96 to 99. Did I have a 96 to 99? Okay. I'm trying to do 2 things at one time. I'm trying to think and do this at once, so just bear with me. 92 to 95, there is none, right? Oh, there's 1.
There's 2 and 88 to 91.
Yeah, I'm sorry. Well, I messed up.
Right.
I messed up. I'm sorry. I suck. I think I should quit. Should be 2, and I should take this one down to what, 1? Yep. Well, it can't be, because 88 to 91, there's only 1. Right? Right there.
Yeah.
And then 96 to 99 is 5. And now, what did they ask for?
The percentage.
The relative frequency is what they're asking for. Remember what I told you, that's equal to all your numbers on the denominator, and then equals this number divided by.
Hubert, that's not right. It should be 20.
Thank you. Let's do this again. Equals this number divided by this number. F forward locked. And then copy that down, and there's your percentages. And when you add them up, they should equal what? 1 or 100. Is that what we had to do?
And then you got to do cumulative frequency.
Really?
Yep.
4, 8, 12, 13, 15, and 20. That should be your answer. Yep. These are not the right answers.
Those are the right answers. The middle one's not the right answer.
No, these are the correct answers that you read.
Yeah.
These are not.
No, those are the right answers.
Okay.
The frequency, the cumulative frequency I got right. The relative frequency I got wrong because I didn't round it high enough.
Ah.
Like I had 24. For the top, I only had 24. So obviously you would want me to round it up higher to the nearest 5 or something.
What did I get?
What, the total?
Is that what it's supposed to be?
It won't let you click on there and see what I put.
I know. I don't know why. But evidently it's time to go because everybody's like going through convulsions. So I don't even know what time it is.
12:30.
I mean, I thought it was 12:35 when y'all got out.
Okay, well,
No, don't take it when I'm in a hurry.
Well, that's good for those people that aren't here.
Yeah. Well, roll is a pain in the butt. I shouldn't have to take it in college classes, but I'm not going to say anything.
very true, Hubert.
But I tell you what, our federal government is cracking down on the 1% of 1% that's getting by with these federal monies. So y'all can be rest assured our federal government is on the what? But when it comes to the borders and everything else, they pretty much suck. But they're cracking down on these people getting